Welcome to this explainer. Okay, so today we are diving into a really massive shift in the 2026 manufacturing landscape. It turns out that procuring metal fabrication equipment, it's just no longer about simply buying hardware anymore. It is all about complex ecosystem integration. So together, we're going to build a comprehensive, rock-solid vetting checklist for evaluating industrial plasma suppliers. We'll cover the whole shebang from the nitty-gritty technical specs right down to those sneaky hidden costs. Let's get into it. So here is our master vetting checklist for today. First, we'll look at the 2026 plasma landscape. Second, hardware vetting. Third, verifying the manufacturer. Fourth, we'll calculate the total cost of ownership. And finally, global logistics. All right, Section 1, the 2026 plasma landscape. Let's get a quick lay of the land. Now, you might be wondering, why in the world are we even still talking about plasma cutting when modern fiber lasers exist, right? Well, the answer comes down to the thickness to cost ratio. Specifically, we're talking about that 6 to 50 millimeter range. And to put that into perspective, 50 millimeters is almost 2 inches of solid steel. While lasers are absolutely fantastic for thin gauge precision work, this thicker range, this is the sweet spot where plasma literally dominates the market for cutting conductive materials. And there's another reason plasma remains the absolute workhorse of the heavy industrial world. It's sheer resilience. Unlike lasers, which kind of need pristine, perfectly clean surfaces to work well, a plasma torch just doesn't care. It easily pushes right through rust, scale, and surface imperfections on carbon steel. That raw versatility makes it totally essential for heavy construction, shipbuilding, and the booming renewable energy sector. Moving right along to Section 2, hardware vetting. Let's evaluate those physical subsystems. This brings us to the really fun part, the technical vetting. When you send out that RFQ, you absolutely must demand these specific 2026 standards. You want high-definition inverters for that laser-like, zero-bevel cut. You need dual-drive AC servo motors for high-speed accuracy, and seriously, skip the stubbers. Avoid them. You'll also want a multi-axis industrial PC controller, automatic voltage sensing for the torch to protect your consumable life, and a stress-relieved welded steel frame. That last one is crucial because it prevents warping over time. But hey, the actual physical metal is really only half the story here. Modern technical procurement means you've got to vet the software too. Specifically, you want to demand a supplier who offers a robust digital twin. This is basically a virtual real-time representation of the physical machine powered by built-in IoT sensors. It is honestly fascinating how having a digital twin is no longer just a cool luxury, it's a fundamental requirement. So what should that digital twin actually be monitoring? Top-tier suppliers will have sensors tracking these 3 key things. First up, consumable wear. This is amazing because it actually predicts when an electrode is going to fail, completely preventing ruined workpieces. Second, gas pressure stability, which ensures your arc stays perfectly stable. And third, electricity consumption. These top-tier IoT sensors aren't just about smooth daily operations. They give you the hard, real-world electricity data you are inevitably going to need for your corporate ESG reporting, which, by the way, is a very strict requirement now for large-scale importers. Okay, Section 3, verifying the manufacturer. Let's talk about mitigating trade risks. Now we're zooming out from the machine itself and looking at the people actually building it. Look, sourcing experts will tell you over and over, you can never buy industrial machinery based on a glossy digital catalog alone. A safe, strategic procurement workflow has to start with aggressive factory audits. You need to verify things like in-house machining, like are they actually milling their own gantries, and you need to check the provenance of their components. Steps 2 and 3 of this workflow cover cost analysis and logistics, which we're going to break down in just a second. But wait, before we move on from the factory audit, I've got a massive pro tip for you. During your audit, always ask for the interferometer test report. This specific test measures the true, verifiable mechanical accuracy of the table's movement. If a supplier kind of dodges the question or cannot produce that interferometer test report, that is a huge red flag. You've got to verify this data before you sign anything. Moving to Section 4, total cost of ownership. Let's capture the real value. Advancing to the financial pivot of our checklist, we hit this brilliant piece of advice. The cheapest machine often becomes the most expensive after 6 months of operation. This is literally one of the most critical lessons in procurement. Buying a machine based solely on its raw initial price tag is a dangerous amateur mistake that will quietly destroy your operational budget. We have to actively contrast the shiny appeal of a low initial price tag with the harsh reality of true TCO, or total cost of ownership. True TCO encompasses all those sneaky, hidden, long-term costs of daily operation. In today's market, true value isn't about saving $5,000 on the purchase order. No way. Value is defined by the machine's ability to minimize material waste, heavily reduce secondary finishing costs, and seamlessly integrate into the software you're already using. So a realistic cost analysis is really built on three main pillars. First, consumables. Don't just ask them for the price of the electrode, ask them exactly how many meters that electrode can actually cut. Second, secondary operations. A cheap machine leaves rough edges, which means your labor costs for grinding off dross are going to absolutely skyrocket. And third, power consumption. High-efficiency units can literally save you thousands of dollars annually if you're in a high-volume setting. Finally, Section 5, Global Logistics. Let's navigate transit and compliance.
All right, we have reached the very last hurdle on our checklist, actually getting this massive 3-meter-wide piece of high-tech machinery across the ocean and safely onto your factory floor. Your logistics checklist absolutely must include demanding strict, seaworthy, vacuum-sealed foil packaging. Otherwise, you're risking terrible transit rust from the sea air. You also need to verify your HS code so you don't end up overpaying on import duties. And finally, lock down a crystal-clear commissioning plan. Are they sending an engineer to your site, or is this just a remote video setup?
It's really interesting to note how your final logistics and support needs will completely shift depending on who you are as a buyer. For instance, if you're a bulk wholesaler importing 50 units, your strategy needs to be laser-focused on standardized spare parts kits and maybe white label branding. But conversely, if you are an OEM brand, your whole focus shifts. You're going to need industrial design localization, custom controllers, and local safety features baked right in. The 2026 industrial landscape heavily rewards folks who treat procurement as a strategic investment, rather than just a quick shopping trip. So as you look over this vetting checklist we've built, I want to leave you with one vital question to ask yourself. Are you just buying a commodity, or are you truly investing in a long-term strategic ecosystem? Think about that for your next big procurement. Thanks so much for exploring this blueprint with me today. Catch you next time.